For the circuit, I have to find what is the value of R for which maximum power will be transferred to R. So what's the value of that resistance, and then what's the value of that maximum power. So we know from maximum power transfer theorem that the maximum power, if we treat R as a load, let's just do that. So R is load, and we know that from maximum power transfer theorem that maximum power is transferred to a load when the load resistance is equal to the line resistance. So for this resistance R, which is load, the supply is this 40 volts voltage source, and the line is the combination of these resistances. So basically, if we want to find what is the value of R which will result in maximum power to be transferred at R, we just need to find what is the value of the line resistance it sees, what is the value of the line resistance that R sees and or experienced by R, and that line resistance will have to be the value of the resistance. So basically we now want to find the Thevenin's resistance, and in order to do that, Thevenin's resistance as seen from here, and in order to do that we have to of course inactive the active sources. So basically we have to make the active sources dead, we can say. So there is only one voltage source which is the 40 volts. We have to short circuit it. So this is our resistance, this is our arrangement for finding the resistance as seen by R. What is let's call it R line, maybe basically R Thevenin. So 80 ohms there, 20 ohms there, and then 10 ohms there, 90 ohms there. So basically what's happening with this arrangement is 80 and 20, these two are coming in parallel, and then 10 and 90, these two are coming in parallel, and they are then coming in series. So 80 and 20 parallel here, and 10 and 90 parallel here. So 80 parallel 20, which will be 80 times 20 divided by 80 plus 20, so that will be 16 ohms. And then here it is 10 parallel 90, 10 ohms and 90 ohms, so that will be 10 times 90 divided by 10 plus 90, which is 100, so that will become 9 ohms. So 16 ohms here, 9 ohms here, that is the resistance seen by R. So R Thevenin, so that is the value is 25 ohms. So that is the value of the line resistance as seen by R. So for maximum power to be transferred to R, the value of R will be equal to the Thevenin's resistance or the line resistance that it sees, that is 25 ohms. So that we have found. Now we need to find what is the value of the maximum power. So let's go back to the original circuit with the value of R now, which we know now. What is that? So this one is there. So what we will do now, we will find the Thevenin's voltage for this one. So we will replace the entire circuit by just one voltage source and one resistance, one line resistance, which we already know. So we just want to find the Thevenin's voltage there. So what's the open circuit voltage there? That's what we are interested in now. So 10 ohms there, 90 ohms there, and then 40 volts there. So with this arrangement, these two are open circuit. So basically we want to find what is the voltage difference from this point to this point. That will be our VOC. So and VThevenin as well. So basically we have this voltage source here and two parallel paths connected to it. So 90 and 10, the total resistance is 100, 90 plus 10, and 80 and 20, so that's also 100. So basically we have one voltage source there and 200 ohms resistance connected to it, and that's 40 volts. So the total resistance is of course 50 ohms. So the total current that's coming out of it, the total resistance, that is 50, because the parallel of 100 and 100 is 50. So the current coming out from the supply is I will be 40 divided by 50. So voltage divided by the total resistance. So that's 4 by 5 amps. So that is the current that is coming out of here. This one is 4 over 5 amps. Let's leave it like that. Now essentially this current will be divided equally between two branches because the resistances are the same. So a current of 2 over 5 amps will go in this direction and a current of 2 over 5 amps will go in that direction. So the voltage drops that will take place, this one is minus plus because the current is going in that direction, and this one will be plus minus. So I may use another color here. So that's plus minus and then plus minus. So these two are the drops. So our VOC, if I, instead of making it more clumsy, if I write what is VOC or V Thevenin, which is of course having polarity plus here, minus here, and if I write KVL for this loop, this particular one, I will get V Thevenin is equal to, let's write the two drops. So one is V, this resistance is 20 ohms, so V20 plus V90. These two are the resistances. Now V20 is of course in the other direction because this is a negative here and this is a positive here. So that will be 20 times negative 20 times 2 over 5, and this one will be 90 times 2 over 5. So this is 40 minus 5 and this is 180 over 5. So that's becoming 140 over 5, which is V Thevenin, which is basically 32 volts. So that's the Thevenin's voltage. We now have Thevenin's voltage. Let's write the Thevenin's voltage there. This is Thevenin's voltage, which is 32 volts, and this is the line resistance, which is 25 ohms, which is the Thevenin's resistance. And R of course will be, for we want maximum power to be transferred to R. That's what the starting point was. So R will also be 25 because that's what we calculated. It's the line resistance. So that's the arrangement, circuit arrangement. Now we just need to find what is the power transferred to this resistance, 25 ohms. So basically we have the power transferred to R, P25, or let's say PR, will be 32 is the total voltage, so is the voltage, divided by total resistance is 50. So that's the current, I square times 25. Actually there has been a bit of a mistake. 140 divided by 5 is actually 28. Sorry about that. So that's 28 here. This one will be also 28 volts. So that's 28 here, not 32. 32 would be 32 times 5 is 160. Sorry about that. So this is 28. 28 over 50, because the Thevenin's voltage is actually 28, not 32. And then this one is becoming 7.84 watts. That's the value of the power delivered to R when maximum power is transferred to R. That's the value of the maximum power basically.